Hello class, I'm working out of your Pre-Algebra book 4.1 Prime and Composite Numbers. We're going to review terms like multiples and factors. If we think about multiples first, remember that it is a number such as multiples of 3, 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and so on. Those are the multiples of 3. What about multiples of 8? We start with 8, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, and so on. Working the other way, we will think about factors. Where multiples are like skip counting, in multiplication, factors are the numbers multiplied together to create a product. So what if we think about factors of 24? Well, first we'd start with 1 times 24. I like to set them out here in this manner so I can think them through all the way from 1 times, 2 times, 3 times, and so on. So doing that, I'd have 1 times 24 is 24. 2 times 12 is also 24. 3 times 8 is 24. 4 times 6 is 24. I've worked in to find all the factors of 24. What are the factors of 18? Going through the same process, I can jot them down quickly. 1 times 18, 2 times 9, 3 times 6, 4, 5, 7, 8, and so on are not factors of 18. So I've exhausted all the factors of 18. What if you're asked to find out whether a number is a factor of another number? For instance, is 8 a factor of 104? You divide to find out. So you'd say 104 divided by 8. 8 goes into 10 one time. 1 times 8 is 8. 10 minus 8 is 2. 4 comes down. 8 goes into 24 3 times. 3 times 8 is 24. And we find out because 8 times 13 equals 104 that yes, 8 is a factor of 104. So in answering these types of questions, what if we had true or false? The first one, 20 is a multiple of 4. Well, if we think it through and skip count through the times 1, times 2, times 3 as multiples of 4, we'd say 4, 8, 12, 16, 20. Yes, 20 is a multiple of 4. What about 9? Is 9 a multiple of 45? No, 9 is a factor of 45. Okay, what about 35? Is 35 a factor of 7? No, 7 is a factor of 35, so we could say no or false there. How about 6 is a factor of 18? Yes, 6 is a factor of 18 because we know this. Okay, you'll be working with prime numbers. Prime numbers only has two factors, one and itself, and it has to be more than one. So let's take the number 2. The only factors of 2 are 1 and 2. What about 3? The only factors of 1 and 3 is 1 and 3. And what about 5? The only factors of 5 are 1 and 5. These are all prime numbers. Composite numbers have several factors besides just 1 and itself. So think about the number 4. 1 times 4 is 4, and 2 times 2 is 4. So this is a composite number with more factors than just 1 and itself. What about 22? 1 times 22 works. 2 times 11 also works. So 22 would be a composite number. What about 17? 1, 17, prime. 13, 1, 13, prime. How about 69? 1, 69, 3, 23, and so on. Composite. There is a divisibility chart on page 137. Look that over. You know 2, 5, and 10 from skip counting by 2s, 5s, and 10s. Add in 3, 4, 6, and 9. Understand how that works. So for instance, the rule for a number divisible by 3 says that if you add up the digits and the digits are divisible by 3, then the whole number is. What does that mean? We have this number, 412. Is it divisible by 3? Well, we can say 4 plus 1 plus 2. That equals 6. 6 is divisible by 3 evenly, so 412 is divisible by 3 evenly as well. So when it says add up the digits to decide, this is an example of what it means. I hope this helps, and I will see you soon.